So I made the decision to make a CLL video today. So it's about the CLL method of 2x2. The method itself is really easy. It's just consisting of two steps. So the first step is to make a layer. So now I made a layer on the orange color, and after you made a layer, there's 40 possibilities left of how the last layer can be, well, just how the last layer can be. And for each case that can occur, you just learn an algorithm. So for instance, this case, I just learn an algorithm which goes like that. That's the CLL method. So on to the first step, which is making a layer. I really recommend to do this on every color. So not only on white, but also on, for example, blue. And of course all the other colors, because if there's a 3-move blue layer and there's a 7-move white layer, of course you have to do the 3-move blue layer, and then your time will be significantly faster than if you do the 7-move white phase. So color neutrality is really important. If you cannot do it yet, then really practice it, because it's pretty, well, you can be fast with only making one color and then do CLL, but you'll always be faster if you can do any color and then do the CLL. So some tips on making one layer is just to, at first, just take longer than 15 seconds, use 20, use 30 seconds to search for a short solution. And well, there's not really much tricks besides, well, I only use one trick to make a layer. So for example, if you already have three pieces, but they're diagonally permuted, so these are opposite, these are opposite, so that's almost complete diagonally permuted layer. And the last piece, you still have to put it in. I actually do it like so. For example, you would put it in, and you have a complete diagonal face. You can solve it with R2, F2, R2, and you have a complete face that is correctly permuted. But you can, while solving that piece, you can do that and cancel a move, and then go on with the F2, R2, and then you made a face. So this is something that you can just use if you're really having difficulties to make a layer. And another, well, handy thing to know that is, if you have two pieces already connected correctly, then if you hold it on the left bottom, you can always make the other two pieces from the layer by doing only moves with the R and the U phase. So for example that. Then recognizing the top layers cases. So that was a layer. Just practice a layer as long as you want. Yeah, just practice it, and the main point is that you can do it fast and in not too many moves. So try to aim for 5, 6 moves. If you use more than 6, 7 moves, then you should really practice some more. Now, to recognize the last layer cases, that's pretty difficult. I actually found out myself when I started this. So this is, for example, an anti-Sune OLL, which is really easy to recognize because there's a dot here and 3 dots there. But if you do the anti-Sune, of course, it doesn't solve it. How I recognize it is actually I made a system for it, and it's always by looking at two opposite colors. So for example, in this case, I just recognize the pattern of opposite colors at orange and red. Just, well, maybe some other time it would be blue green, and some other time it would be white yellow. But in this case, it's this pattern that you've got a bar of opposite colors here, so orange red, and the bar on left of red and orange. So that tells me which case I have. So for example, it would be this case. I just linked it to that pattern. And other cases, so for example, this case, I recognize it because I have a bar of opposite colors on front and left side, front and back side. So that's why I know it's that case. So in the description I'll give, so each case will start with how I recognize it by just pointing it like these are opposite, these are the same, and these are just completely different, etc. I hope you understand that, and don't fall asleep while watching the video. And I'll just display it on the yellow face because most people are doing it on the yellow face, though I obviously advise to do it color neutral, because if you're not color neutral, it's pretty it's pretty pointless to learn full CLL, because CLL means if you learn CLL, you will obviously have the intention of becoming really fast, but too bad you could, because you take a lot of effort in learning all 40 algorithms. So if you're not even color neutral, it's pretty, yeah. If you cannot even make a layer on every color and then recognize the pattern, it's pretty, yeah, well, pretty dumb. So starting off with the Sune case. The Sune case is recognized by having a point here, and these three other stickers are here. So the Sune case I recognize, like I told you before, with same colors here and here, of opposite colors obviously. The algorithm is like this. So I will display the algorithms here in the bottom. So if they're not there, just don't complain, because maybe I didn't have time yet to put them there, but they will be there, I promise. So this is the Sune case where I have to switch the right two pieces. I recognize it because we have a pattern of those two here and those two here, and it's like right left are the same. So these two are red, these two are orange. So the algorithm is like this. Pretty obvious. Going on to the pretty well-known Nicholas case. This case is recognized pretty much the same, but the difference here is that these two are not the same, and these two are like these two are not the same. So these two are opposite, and these two are opposite, and these two are opposite. So like it's just a crisscross. So the algorithm is obviously like that. So chook. So this case, it's where you have to switch the. Let me check the front two pieces, and I recognize it because by seeing the pattern of these two and these two, and these two are the same and these two are the same. There's also a case where these two are opposite and these two are opposite, but I'll come to that later. This is the algorithm. Pretty nice. So it's this. So this is the case I just talked before about. So now these two are opposite and these two are opposite, so the pattern of these and these two are the same, so on the top and on the side. This algorithm, it switches the back two pieces and keeps the front two pieces in their place. It goes like this. So to do it fast. This is the Sune case where you have to switch two pieces diagonally, so it's either those two or those two. So the recognition of this case is done by seeing these two and these two. So it's the same recognition as the normal Sune case with no permutation, but now at the Sune recognizing these two were the same and these two were the same, and now it's the other way around. So the front two and the back two are the same instead of the right and left and the left two. This is the algorithm. Moving on to the anti-Sune cases, you recognize those by having a point here and here, here, and here. The recognition is the same as with the Sune case, so these two are the same and these two are the same, so right and left. And this is the algorithm. So I figured it was better to do the diagonal case after this, because it's recognized the same way. So now you see that these two are the same and these two are the same, just like at the Sune case. So the back two are the same and the front two are the same here, so green and blue. This is the algorithm. This is the case where you have to switch the pieces on the right. So you have the pattern of these two and these two, where the right and left ones are the same. So the algorithm is like that. Going on to the left side switching, so the pattern is the same, but now these two are the same and these two are the same, so it's like opposite of the one before. This is the algorithm. The algorithm for switching the back two ones. So it's this and that pattern again, and it's the front two and the back two that are the same. The algorithm to switch to front two ones. It's the same recognition again, but now these two are the same and these two are the same instead of these two and these two. This is the algorithm, so it's like tick, 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 tick. Going on to the pie case, or I call it the ears case, because you've got two good ones and two ones on the left and the right, just like your ears, of course. So I recognize this because there's a block here which is complete, and there's a line here which is also the same, and of course these are opposite colors. So the algorithm is like this. The algorithm to switch the right two ones, actually you can see it as a J-perm, but for this case, so here's a bar which is correct, and you just see that the other bar is on the right side, which is how I recognize it. I started from this angle, and it's just a J-perm which you can do, which I use from, for example, this case for if you look at red, orange. So this is the algorithm. The algorithm to switch to one on the left. You can recognize it by seeing that here's a bar complete and here's a blue one, and you obviously know that the other blue one is here. So the algorithm is like this. The algorithm to switch the pieces on the back. This is actually one of my favorite algorithms. From this angle you can recognize it because you got here two green ones and here's a blue one, and the other blue one's here, but I start the algorithm from this angle, and there you see that here the pieces are the same, whereas here the pieces are opposite. The algorithm is really fast and really easy, so it's like that. So if you do that fast, you can do it like chook, and you can get some really good times if you get this case. The algorithm to switch the pieces on the front, you can recognize it same as the other case. It's equally nice, but now it moves around the left side, so you see that these two pieces are the same, and here's a red one which is the opposite, and you see it from this side just like the previous one, that now these two are opposite and these two are the same, these two are the same. So the algorithm is the same but just mirrored on the left. Now the algorithm for crisscross, so diagonal permutations, you can recognize it by having this and this pattern, just like the one with no permutations on it. But now these bars on the top and on the side are opposite, so these two are the same and these two are the same. The algorithm is like this. So you actually end it upside down. I kind of like the algorithm. Going on to the, well, I don't really know what you can call this case, but I guess you can call it the triple Sune or whatever. So the case where you have to switch to, well, don't switch anything, so it's just orienting two pieces. You recognize it because these two are the same, and well, you just don't see anything of the same here. So these two are just completely different. I actually start the algorithm from this side. It goes like that. The case where you have to switch two on the right ones, you can recognize this is the same as the Sune cases with no permutation. So here's two of the same on the right side, and here's two of the same on the left side. This is also a very nice algorithm. So the case where you have to switch two on the left side, I don't really think that this algorithm you should use, so I actually suggest getting another algorithm. If I find another algorithm that's better, then I'll just post it here in the sidebar, or well, at the comments, and then just ignore what I do now. Because yeah, well, the recognizing like this, you see these two are the same on the top, and these two are the same, but the algorithm I do is like that. So it's YZ. But because of that Z at the beginning, I think it's pretty slow. The algorithm to switch two pieces on the back, you can see that the recognition is almost the same as with the case to switch two on the left. So these two are the same again, but now these two are just a completely different color. The algorithm is like this. the algorithm to switch to pieces on the front, you can recognize it because these two are the same, and well, no, these two are opposite, I'm sorry, and well, you can see that these two are the same, but personally I just recognize it because, well, there's just nothing else here that's the same, so it's just these two opposites, and further there's nothing that matches. This is the algorithm. It's really nice too. The algorithm to switch two pieces on, well, on diagonal sides, you can recognize it because these two are the same, and further here there's nothing that matches of the same color or the opposite color. I actually use an algorithm of the 3x3 for this case. So it's this case on the 3x3 that I use the algorithm for, which is this OLL. So on the 2x2 it's this. The case of eyes, because they point towards you, and ears, because they're on the side. So the eyes, ears case. This is the case where you don't have any permutation at all. You can recognize it pretty easily because here's a bar complete, and here's just stuff that's not the same, so nothing of the same or opposite color, and the opposite colors are here. The algorithm is pretty easy, so it's F, then twice sexy move, F minus, so it's this OLL. Pretty nice. The algorithm to switch two pieces on the right, you can actually recognize it really easily. All of the eyes, ears cases are really easy to recognize because you can just recognize them by looking at the top of the puzzle, because there's no yellow pieces here, so you can just look at the top and recognize them. So these two and these two are just same colors, so these are of opposite colors, and it's like that. So I started from here. So the last case, this is the single eyes case, because, well, there's eyes pointing towards you. Non-permutation, so these are the same, so you can also have it from this. So anyway, these two are the same, and here's one of the same, which is the opposite, and the other one is of course here. In other words, you have a bar here and there's nothing on top. I started from this angle. I would actually almost forgot that there's also a case where there's yellow all on top. So there's two cases, just so it's the T-perm, which is two pieces switching on the right, front, left, or back. I actually use a lot of different algorithms for this. So for instance, I get it from the back. I do it the same as with this OLL, where you have to switch two pieces on the right with the ears case. So it's like so for example, you have to switch two pieces on the front. I would actually do this. To switch two pieces on the right, I would have to do this. Two pieces on the left, I would do it this way. And then the last case, switching two diagonal pieces. You started with these two solved, so you don't need any other move at the end. It's pretty, well, for CLL it's okay, but if you get it and you use it for Ortega, you don't really like this at all. So it's like this. It's not like that, but whatever. That. So fast enough. That was about it, I think. Some extra tips for becoming even faster at 2x2 using CLL is to be able to determine the U correction you have to do after each algorithm. So for example, you have this algorithm and you want to get the U correction, if you want to know the U correction after you did the CLL. So for example, this case, I know that after I do the CLL, I still have to do a U minus to set it correct, because I know that if I put it at this way and this lines up, it actually solves everything. So same for the Sune case, that if you started from this side and you notice that these two are opposite, then you know it's no U correction. And like for example the anti-Sune case, and you see that everything is already at the correct place but not oriented, so this piece is actually solved, then you know it's a U2 afterwards. So you can do it for every algorithm and then learn it by heart. So you actually save a little bit of time because of that, because well, it's just one U2 case. You might think it's just one move at the end, but you also have to take into account that you also have to recognize which U move you have to do if you don't know the adjust U phase tricks for this. So this was actually the whole CLL algorithms that I use. Some of them are a little bit bad or outdated or whatever, but I think I'm happy with most of them. Maybe I'll just make a tutorial about Gimon or Ortega after this, but I think CLL is the really good start to be really good at 2x2, and maybe I'll just learn the rest of EG2, so case 2 and case 3, and I'll just make a video like this too. Thanks for watching.